live now, folks. Okay, question number 3. It says that U, V, and W are points on the circumference of a circle. Okay, U, V, and W. U and W is the diameter of the circle. Write down the size of angle U, V, W. Okay, right. So write down the size of angle U, V, W. Okay, so let's have a look. Where's that? U, V, W is this angle here. And we know that that angle is 90 degrees. Why is it 90 degrees? Because the rule is the angle
In a semicircle is 90.
That's it, the angle. Oh, that's quite a bit funky. The angle in a semicircle is a right angle. Can we please write this down if you haven't already written it down? Okay. Is a right angle. Okay, that's the answer to question 3 part 1 and 3 part 2. The next question says x, y, and z are points on the circumference of a circle. Center O, angle XOZ, which is this one here, is 140. Work out the size of angle XYZ. XYZ is this one here. So we know that that angle is equal to 70 degrees. So we write down 70 degrees. Okay, now the part of the screen that you can't see, which I'm going to read out to you, says give a reason for your answer, and that is called B part 2. So B part 2, I'm going to do it up here. So B part 2. Okay, we have to give a reason for this answer. So we're going to write down rule number 2. And the rule number 2 states, what's the rule number 2? So the angle, okay, what is the rule? The angle subtended at the center of a circle is twice the angle subtended at the circumference. We have to write that down for the answer for part 2. So the angle subtended is the mathematical word used. Angle subtended, I don't know why this is coming out, the handwriting is not coming. Okay, right, I'm going to try something a bit different, folks. Let's try texting mode. Okay, let's do it in white. Okay, let's do it here. So you say there. Let's put down the angle. So I can't agree more. I find it difficult to write with this particular software. Subtended. Okay, angle subtended at the center of a circle. Okay, at the, let's do another one over here. Okay, the angle subtended at the center of a circle. Okay, is twice the angle subtended at the circumference. Okay, now. So why we need to... Okay, right. The angle, I'll write down the angle again. Subtended at the Okay, so we tried doing up here, it was a bit of a mess. So it said the angle subtended at the center of a circle is twice the angle. I want the angle over here again. Subtended at the circumference. That's done. That's the explanation for that question, part 3. We're going to go on to question 4 now. Here comes our next question. Let's clear that. Okay, right. Right, question number 4 is over here. A star next to it. Diagram not accurately drawn means don't start measuring angles. So it's given us here x and w and z are tangents which touch the circle at point z and x. Okay, we know that this angle is 60. It goes to work out the size of angle xyz. So let's have a look. Where's xyz? Xyz is this angle here. Okay, folks, are we focused on reading? XYZ is, we have to work out this angle here. That's angle XYZ. Right, let's start working out this question from what we know. Now, what is this angle here? And what is this angle here? Okay, these angles are the right angle. Why the right angle? Let's write that down. So first, what do we say? We have to write down here now our explanation for that. So angle, okay, no, I don't want that. Push. Okay, Mr. Saf, can you focus on the lesson, please, rather than looking around the room, yeah? Is there any chance you could do that for us, please? Thank you very much. Jazakallah khair, barakallah fi. Okay, angle WX0. Angle WX0 is equal to angle WZ0. WZ0. Which is equal to 90 degrees. So we're making a statement that this angle here is equal to this angle here, which is equal to 90. Okay, now why is it 90? Now we've got to give the explanation. So the explanation is, what is the explanation? So that is rule number 5. So the angle between a tangent. Now the tangent here is WX and WZ. So WX and WZ, put that in brackets. So that's what I'm talking about. The angle between the tangent and, okay, and the radius. Okay, where's the radius? The radius is OX and OZ. Is always radius drawn to the point. Okay, is a right angle. Is a right angle. That's the first explanation for the first bit. So, because we know this is a tangent and we know that's a radius, these two must be 90. Now, we're going to work out angle now ZOX. That's the next page. So, we're going to say angle ZOX is equal to, what's angle ZOX equal to? Angle ZOX is equal to what? 120. So I've given you the answer, but now I'm going to explain it to you. Y is equal to 120. Let's pick this pen here. So I've made a statement that this here is equal to 120 degrees. Okay? You know that's 90, you know that's 90. Now, let's look at the reasoning for that. Okay, Mr. Saf, I'm over here, I'm not over there. Seem to double of me. Okay, now, what do we say? Y is equal to 120. So we say here that the angle sum, what shape is this here? What shape is this? What is called? Quadri. Okay, the angle sum. Okay, angle sum of the angles in a quadrilateral now each time I make so talk about something general, I'm going to make specific. Quadrilateral I'm talking about is going to be OXWZ. So I'm being very kind of specific on what I'm talking about, OXWZ. So it's that one. So angle sum of the angles in the quadrilateral is 360. 360 degrees. So that's my answer. This is part of my explanation. I'm going to give more of the explanation here now. So therefore, we're going to do now, where's it gone? So 360 minus the 60 that we know, minus the 90 that we know here, this one here, and that the 90. Minus the 90 is equal to 120. So that's where the 120 came from. Okay? Has everybody got all that description down?
Yeah.
In red. Okay, Mr. Harun, have you got the description down?
Yes, sir.
I know my screen is big, but it's not that big. I can't see what you're doing. Okay, right. Okay, let's go on to the next page. Let's clear that. Clear it. Question number 5 now. Welcome back. The diagram shows the circle center 0, A, B, C are points on the circumference. DCO is a straight line. So we have DCO is a straight line. DA is a tangent to the circle. Angle ADO is 38. Work at sides of angle AOD. That should be nice and straightforward. Now let's have a look. Now this here is a radius OA. This is a tangent. So they will always meet at what angle?
Right angle.
Right angle. If they meet at right angle here, so that's 90, that's 38. So these three angles would then add up to 180. So 180 minus 90 minus 38 will give you an answer of, so what is the angle there? MashaAllah, 52, good. Okay, so now let's write down some of that mathematics for that. So we can say now, okay, so let's write down some things that we know. So we can say first of all, angle DAO, oops, is equal to 90. Why? So the answer will be the angle between a tangent. Okay, what tangent is it? The tangent is AD. Angle between tangent AD and a radius. And the radius AO is 90. That's why it's 90. So explain it. Okay, come on. Ladies in the back, can we write in small bits paper? The work you're doing on your exam paper, please. Write this down. This is the crux of it. Okay, so we worked out angle that one. We work out AOD now. So what's angle AOD going to be? So we can say now here. So angle AOD. Whoops. Oh. Okay. Right. Let's go back. So we say angle AOD is equal to, what do we say it was? Angle AOD is equal to 52 degrees. And why is it equal to 52 degrees? The answer is angles, the internal angle sum, internal angle sum of a triangle. Now I'm going to define the triangle I'm talking about. What triangle is this? OAD is 180 degrees. So I've given the answer. I'm start explaining my answer. Now I'm going to do a bit calculation. So 180 degrees minus 90 degrees minus 38 degrees is equal to 52 degrees. So that's where I got my answer from. That's all the background behind the 52. So 52 is the answer, and I've explained it all. Okay. Next part of the question. So we've done part A. Because work out the size of angle ABC. Okay. Angle ABC. Okay. Right. Right. Now, if we have to work out this angle here now, ABC. Now, if you look at the shape which I've highlighted here in yellow and then indigo over here, that shape follows rule number 1. Rule number 1 states angles standing on the same arc of a circle are equal. Okay, that's if they're on the same arc. But it's not rule number 1 as such. We are actually looking at rule number 2, rule number 2. The angles which an arc subtends at the center is double of that which it subtends at the circumference. So the yellow here, highlight here, is the angle subtended at the center of the circle, and the indigo one here, highlight, is the one subtended at the circumference. So we are now going to make another statement. Okay, so we are going to now say Okay, the angle, okay, subtended. Okay, the angle subtended at the center. At the center of a circle is twice. Center of the circle, where's the center of the circle? Okay, first of all, center of the circle is going to be AOC. That's the center of the circle. Well, we just write down O. That's the one I'm talking about, that's the angle. So the angle of the angle AOC is twice the angle subtended at the circumference. The circumference is going to be ABC1. Okay, so what is that going to be then? So this one here is double of that one. So what's the angle going to be equal to then? It's going to be equal to 26. This one here is double of that one. So this is half of that one, isn't it? So that's the answer for that one. And I'll give the reason for your answer. There's the reason. So it wasn't actually what I mentioned first. Angles and the same arc of a circle equal. That's one's rule number one. This is not. This is rule number two. Rule number two is the angle which an arc subtends at the center. Okay. The angle which an arc. Now the angle subtended at the center of a circle is twice the angle subtended at the circumference. That's another version of it. Okay, that's end of question number 5. That's all parts done. Next question. Okay, question number 6. In the diagram, A, B, C, and D are points on the circumference of a circle. Center angle BAD. Center O. Angle BAD is 60. Okay, right. Work out the value of angle X. So what can we say about angle X? We can say the angle X is equal to what? What's the angle X going to be equal to? So that's 60 here. That will be what equal to? 120. Okay, 120 degrees. Okay, give a reason for your answer. So part 2. Part 2. Okay, let's go to the brush. Right. Okay, A part 2. What do you say for that then? Ifra.
A part 2.
Alright.
The angle which an arc subtends.
Okay, the angle
center.
which
An arc subtends.
Yeah, this arc subtends at the center.
At the center of the circle
At the center of a circle. Center of a circle is twice what we just written is twice. Okay, the angle subtended at the circumference. Okay, next question. Work out the value y. Now, if we look at this, it's the same rule again. Now we're going to have to look at, okay. Now, this angle y is connected to which other angle? This angle here. Angle y is half of this angle because of the same rule we got over here. So what's that going to be? Now, what we just worked out, we worked out the angle, which one have we just worked out? We worked out angle x is equal to what?
120.
120. If that's 120 here, then these two angles around a point add up to 360. So this angle here will be what? 240. Okay, now, This angle here is half of this angle here. Sorry, this angle here is double of this angle here. So y will be equal to 120. So y is also equal to 120. Okay, why is that? Okay, well, we kind of done it the long way, the quicker way of doing it. Okay, rather than doing what we just done here, I'm going to quickly rub that out and give you the quicker way. That is one way we could have done it. I'm going to rub this one out. Rather than considering this way, that's slightly longer. Let's look at this way. Now, if I highlight this angle here, and I highlight this angle here, can somebody tell me about how these two are connected? This here is called a quadrilateral. So what we can write down now is...
That's what I got.
Well, go on, then give that to me then.
The opposite angle is opposite quadrilateral. Add up to 180.
Excellent. That's a more quicker, and so the opposite. So opposite angles of a cyclic quadrilateral
Add up to 180.
add up to 180. Therefore, y is equal to 180 minus 60 is equal to 120. That's the reason why that's 120, and that's the quickest and easiest way to do that one, rather than a slightly long way that we've just done. Let's move on to question number 7.
So I think we should say that's number.
Yeah, so I don't